Okay, we are now live. This might seem kind of corny, but I think we should, let's quick review the rules. I think, how many are there? 4 or 5? I think there's 5 now. So the rules for logic, first we have the AND connector. You remember the rule, only true when both are true. Then we have the inclusive OR, only false when both are false. And we got, the exclusive circle with a cross in it. That's the exclusive OR. Only true when what? They're different. Right. And then its opposite is when you have one bar, and the arrows go both ways. That's only true when they're alike. Just the opposite of the exclusive OR. Negation, of course, that's just what? Opposite. And then there's one more we've had. I might be pointing the wrong way for you guys. Which direction is this going? From right to left?
It's going to the right.
It is. See, everything's reversed on my screen. That's why.
If you're referring to the if then?
Yeah, I'm wondering, the arrow I'm making with my hands, is it?
Yeah, you're right.
It's pointing to the right?
Mm-hmm. Yep.
Yeah, see, on my screen it's the opposite.
Oh.
It's just a quirk of, whatever. Anyway, the rule for that, the conditional if-then, is what? This is kind of the weird one. Only false when the first statement is true and the second statement is false. So hopefully you guys are, kind of drilling yourself on those? Because that's kind of the key to really doing well in this chapter. And that there isn't that much to remember, but you really need to know those really well. Okay, so review over. Let me do the. I'll turn.
Do you do the two-sided arrow as well, Ron?
Yeah, this one.
Yep.
That's the one that's true only when they're alike.
Right.
Right. We did that one.
Oh, I didn't remember you saying that.
Yeah. Okay. So I'm going to share screen, and it should be easier this time. And then we'll get the pictures out of there. So you guys should be seeing my screen now.
Yep.
And I'll get the pictures out of the way, so hopefully we can see a little bit better. I'm just stuck on this one number. We could go, let's see, am I in the right lesson? Yeah. So here was the assignment for that first lesson on Thursday night. Questions on that?
Could we go over number 11?
Absolutely. Okay, number 11. Get a chance. I just improved my slides a little bit. I stuck some of the book problems in the background so we wouldn't have to go back and forth to the book. So here's number 11. So P is it is raining. Q is I will go to the beach. So did you want to go through all 3 parts of 11?
Mainly number C. I wasn't understanding, like, finding the truth values. That was throwing me off.
Yeah. Okay. I've got C. That's a perfect match for what I've got up here. So C says, assume that P is true and Q is false. So in other words, what we're doing is one line of a truth table. Get my pen going here. So see, this is just one line. Normally we would have what, like 4 lines in a truth table? 4 rows. Welcome, Brittany. I see you just joined. Glad to have you. At the current time, Brittany, we're looking at number 11 on the 3.2 assignment. Okay, so by the way, who asked me this question?
Rebecca.
Oh, I'm sorry, Rebecca. I still don't have all the voices
Okay,
down.
thank you.
But anyway, you know what I mean when I say normally a truth table has what, at least 4 rows in it?
Yeah.
So what they're saying is just look at one row, the row where P is true and Q is false, this part right here. And now, I mean, and now I guess we're supposed to do the but. If you go back to part A, remember but is the same as and, right? So P and Q, what? That's only true when they're both true, so that one's got to be false. And P inclusive or Q is what? Only false when they're both false. Well, they're not both false, so that one's true. So, I don't know, hopefully that makes some sense. That's what they were looking for you to do in 11 part C.
So is that whole line there the entire answer?
Well, really, just, I mean, technically these are the answers. But yeah, the whole line, that would be great if that's what you had in your notes. But I mean, do you see what we're doing? In effect, they're asking us to do just one row of a truth table. I'm not sure I got through to you. Did you want to ask a follow-up question? Or
I think I get it now.
okay, good. Does it, now that it's up here, anybody else want to ask anything about number 11? Okay, who's next on 3.2? Thanks for asking the question, Rebecca. .2 question. Okay, not hearing any. Going once, going twice. Anybody have a 3.2 question? All right. Then I'm going to put this down and we're going to move to the next lesson. Here was the assignment on 3.3. This was the lesson about the conditional and the biconditional. What would you like to talk about on lesson 3.3?
I had most of my issues more towards the end of the questions.
Well, that'd be fine. Where would you like to start?
So let me look at it real quick here, Ron.
Okay.
So you know when we were like 43, 45, 47 and we were changing the statements? Number 47 kind of threw me off a little bit. I wanted to write something else in the book, wrote it differently than what I would have thought it should have been.
47.
Correct.
Show by means of the statement P. Okay, let me just do that one. I don't have that one, and that's just fine. So let me, you're going to see the wrong page there. Let me put in a new one, and we'll do number 47.
And should I be feeling awkward that sometimes I can't write out the symbolic form? Because I feel like if I can write out the symbolic form, it might be easier to write some of the statements.
Okay, isn't 47 all symbols?
No. You're supposed to write it in words.
I must be looking at the wrong place. Are you on lesson 3.4 now?
3.3.
Oh, remember I'm sorry. That's correct. I'm looking now. I know what's wrong. I'm looking in the wrong place in the book.
Okay.
Thanks for straightening me out. All right, number 47. Yeah, if you can write it in symbols, it shouldn't be too hard to translate it back.
And that's where, remember I told you, like, sometimes it's clicking and sometimes it's not?
Yeah, well, I don't think that's real unusual. It does take a while to get used to this. So let's try to analyze 47 together. Okay, number 47. Evel Knievel will lose his life if he is careless. So I'm gonna just call C careless, and I'm gonna say L will lose his life. What was the directions just to write it out?
Negation.
Okay, so first of all, does this make sense for the original?
Seeing it written when you write it, yeah. I tried a couple of different things, but
Did you catch the problem with English here?
I did.
In English, you can throw if wherever you want, but in logic, you always want if to be first. So even though they ended it with if he's careless, notice I began the symbolic with if he's careless, then he will lose his life. Okay, now let's talk through the negation. Actually, this one's a little bit tricky, but think about the if-then statement. In the truth table, what was the only thing that would make an if-then statement false?
If the first one didn't happen? Or if it was false from the first one?
Yeah, I mean, in an if-then, isn't it only false when the first one's true and the second one's false?
Correct.
So what we got to do is make the first part true. So here's one way you could do it. You could say C and not L. Or I would also be okay with if you wrote it this way. But in both cases, do you see how I kept the first part the same and I negated the second part? So
that was my question. Do we always negate only the second part of these statements, never the first, or?
Well, this is only true with if-then statements.
Okay.
See, if-then just happens to be an operation in logic that only has one false in it. That's not true of the other ones, right? I mean, it might usually there was a pair of each. So one unique thing about if-then is it only had one line that was false. So anyway, so what I'm telling you here only applies to if-then statements. So I would accept either, this first answer here or this second answer.
But they have them written out in sentences.
Oh, okay. Well, yeah, let's translate them back to sentences.
So it came out to be Evel Knievel is careless, but he does not lose his life.
Yeah, and they translated this as but another way to translate that is and. So I would also accept Evel Knievel is careless and he will lose his life.
So could I have used and or but?
Yes.
Okay.
Even though the book probably only has but, and is perfectly correct.
Okay. That's what kind of threw me off, too.
So here's that but and in logic are basically the same thing.
And number 51 was the same way for me. I wanted to write it one way, and the book wrote it a different way.
All right, let's just talk about it. This is good stuff to go through. Okay, 51. All right, 51. Write each statement in if-then form. Gotcha. Joe had an accident, or he would be able to get car insurance. Oh, that is really...
So, and I wanted to put if Joe had an accident and keep it the same like in the beginning and change the back end, but they changed the front end and left the back end.
Okay, Joe had an accident. or, and I'm assuming this is the or they're talking about, Joe had an accident, or he would be able, he could get car insurance. All right. Yeah, this is really, I'll be honest, this is really a stinker.
Because they
and it's a stinker because I didn't get a chance to talk to you about what, an identity?
Mm-hmm.
And the identity is this. If you, let's see, if you have, let me just go to P's and Q's again. If we had this general conditional statement, that's equivalent to so what they were doing, although I never see an if-then mentioned here, do you? Well, they kind of imply, this is a problem with English again. It's kind of implied with the words, Joe had an accident or he would be able to get car. So in other words, they're kind of like, if Joe had not had an accident, then he would have been able to get car insurance.
Right.
That's where they get the no on the beginning. Got that? If Joe had not had an accident, then he would be able to get car insurance. But that's almost more of an English problem than a logic problem. Mm-hmm. So I'm not worried that you had a little trouble with it.
Well, the question wanted us to change what they had written into an if-then statement.
Right. I know. And what I'm saying is that's really that's more of an English problem than it is a logic one. But anyway, you're going to see it's a little bit. I shouldn't have given you that question yet because I'm going to be teaching you this. It's coming in one. It's coming in one of these assignments. I don't remember exactly where. That is equivalent to not P or Q. Well, then we would have known right away. Okay, so this turns out to be really important when we get to the end of the chapter, but we haven't had a chance to teach that yet. Well, if you'd have known this wouldn't have been that hard of a question. So I probably should have not put it in there. But anyway, if you look at it real carefully from an English point of view, what's another way of saying Joe had an accident or he would have been able to get car insurance? Oh, what they're saying is if he hadn't had an accident, he probably would have been able to get car insurance. It's that, I don't know why we do that. It's like soap opera talk. This is my, have you ever noticed how on soap operas the general theme is whatever you do, don't tell the truth? I don't know why. They just can't come up. You know what I mean? I know that's half the show. Oh, if only Joe knew that his pet turtle died. Oh, I'm not going to tell him because then he'll, you know what I mean? Obviously, they don't do it with turtles, but, you know, should I tell him that that's his baby? You know, all that baloney. Okay. And they talk around it. Well, that's what this is. This is kind of talking around, and unfortunately, there are many ways to say the same thing in English. So the bottom line is, I'm glad you asked about this one. It wasn't the best question yet, and I probably should have waited with it, but I did not notice that. Thank you for asking it.
Okay.
Yeah, I would have had trouble with that one too. It just, but if you think about it, away from math, I think you can come to the conclusion. You know, even though there's no if-then in there, you can see it kind of behind the words, can't you? Mm-hmm. He can't. He had an accident. Otherwise, he'd have been able to get car insurance. And if you read between the lines, you can tell that the accident caused him not to be able, you know, yeah. Okay, thank you. Another question on 3.3.
Can we go over like the 5 through 11, I think I understand it, but I'm not 100% sure. It was more of those truth value statements with like math problems in them.
Yeah, let's take a look at number 5. At least we can start with that. Okay, I don't have the problem here, so let me go read it. Find the truth value of each statement. No, I've got the wrong page, don't I?
133.
Okay, well, this isn't the right one, so let me just do another one. Okay, let's just make a slide. So on number 5, we've got if 2 plus 2 equals 4, then 8 equals 5. Okay, so is that true or false? Well, it's all based on one important concept. What's the only time an if-then statement is false?
When the first true and the second is false?
Yes. And in this one, the first one is that true?
Mm-hmm.
And the second one is?
False.
So that tells me this whole thing is false, right?
Yep.
So that's really is. They're just practicing to see if you remembered that. How about numbers? As long as we're talking about that, look at number 6. If 2 plus 2 equals 22, then 8 equals 4 plus 4. So there, the first part is obviously false, right?
Mm-hmm.
So I don't have to look any further. That statement's got to be true. Why? Because in an if-then, the ironic thing is in an if-then statement, if it begins with false, it's guaranteed to be true. Why? Because the only time an if-then statement is false is when the first statement is true and the second statement is false. Well, the first one's not even true. That's kind of like what we were talking about. If pigs fly, then I'll give all of you $1 million at the after the final exam. Well, I can't lie at that, at least because, except for that crazy commercial I showed you, pigs don't fly. So when you start an if statement with something that's clearly false, even though it's kind of nonsense, it's not a lie. It's considered true. I don't know. Does that make it? So all those questions from 4 through 7, we're practicing to see if you remembered the if-then rule.
So, Ron,
Yes.
this is recorded, and if us girls get together and make a pig fly, we each get $1 million?
Yeah. And my life is basically over. You could add that on the end. But that's okay. If you guys come and visit me in poor person prison, that would maybe bring me a cookie periodically. I'll follow through. Wow, you guys found my weak spot already. So did that answer the question about those?
Yeah, I think that the math was just throwing me off with like 2 plus 2 equals 22, and I was just like, I don't.
Yeah, what kind of math is that, right?
Right. Yeah, I think I get it now, though.
But and you're right. The answer to your question is that's false math. Oh, if the first part is false, you got to get past the bad arithmetic and just
Right.
look at true false. Yeah, I don't blame you. That would be disconcerting. Yeah. Okay. Well, what again? I'll give some. Is there another question somebody would like to ask on lesson 3.3? Thanks. By the way, as hard as I know it is for you guys with your schedules and everything to get to get a lot of work done from the assignments that you only had on Thursday night, boy, if you can even get a few in, it really helps, because otherwise all your questions will get jammed into next week Thursday, and it's just not as easy to handle them if you do it all in one swallow. But anyway, I know that's hard to do. So anyway, you guys had good questions. Thank you. Okay, let's start the new lesson, lesson 3.4. Actually, this is a little review because I'll just go ahead. Here's what the lesson. Here's the title of the lesson. It's in your book too. It's in two parts: variations of the conditional and implications. So I literally will have to teach this lesson in two parts. So first we'll do the variations of the conditional, and secondly we'll talk about implications. Like I was telling Cindy when she got on in the beginning here, there are no new rules today. So anyway, now I wanted to show you a review thing. I thought this was kind of interesting, and you guys, I think several of you last time asked, how does this apply to life? This is really a good example of that. Okay, here we have a courtroom scene. And just look at the dialogue at the bottom down there. You see where it says prosecutor, defense attorney, and judge? So the prosecutor, that's the guy trying to nail the guy, says, if the defendant is guilty, then he had an accomplice. And right away the defense attorney says, that's not true. So immediately the judge called a mistrial. What? Okay, check it out. It's if the defendant is guilty, then he had an accomplice. That's an if-then statement, correct? Mm-hmm. And when is the only time an if-then statement is false? When the first part is true and the second part is false. Look at the first part. He basically admitted that the defendant, the guy he was defending, is guilty. Do you see that? Does anybody see that? No.
I see it.
I seen the if-then statement, yeah.
And do you get that the only time an if-then is false is when the first part is true?
Yeah, I get that.
So in effect, the defense attorney just claimed the guy he was defending is guilty. By the way, you can't. That's against the law. You can't go against your client. You can't turn on him. And so immediately the judge, being swift on his logic, said mistrial, and he was right on the money. Yeah, you can't. It's not fair that you have somebody defending you who's against you. Okay, so anyway, that's another good example, very simple, a good example of logic. And as a judge, of course, you better be good at that. But you know, you'd want to be aware of that too if you were on trial. Could affect the next many years of your life. Okay. So now let's get into the new material. Okay. So I already showed you the title of this lesson, and you'll notice there's kind of a graphic down below it. Okay, so what we're doing here is we're going to begin with a good old if-then statement. If P, then Q. Now, there are ways to twist this around. As you can tell in the second line, what happened? They just took the Q and the P and swapped them. Do you see that? If Q, then P. Whenever you just take the if and the then and switch them around, that's called the converse of the statement. Converse. Okay. The second line after that, you see it says if, maybe you can't tell, those are nots. If not P, then not Q. What did we do? We left the P and the Q in their natural positions. We simply negated them both. That has a name too. That's called the inverse. Please note, the converse and the inverse are not the same. Well, I mean, you can just tell that by sight. And now this is the one that's the most important, the last one. What if we swap the two letters and negate them both? So you notice here we have the P and the Q swapped and we negated them both. That is called the contrapositive. This is the most important of the three. We got three ways to rewrite a statement. Number 3 is the most important. And the reason is, guess what? When you do both like they did in step 3, it's exactly equivalent to the one on the top. Well, I'm jumping the gun a little bit. Let me go to the next page where I show some of this. Yeah, so here's basically what I just told you a few minutes ago. The contrapositive is always equivalent to the original statement. Let me give you an example of that. If I know this is corny, but let's use this as an example. If it rains outside, then the sidewalk will get wet. All right, let's just say, so in other words, P is it rains outside, and Q is the sidewalk gets wet. Okay, so there's our original. If it rains, then the sidewalk will get wet. Okay, what's the contrapositive? If the sidewalk didn't get wet, then it didn't rain. Can you tell that those two statements say the same thing? Let me try that again. If it rains outside, then the sidewalk will get wet. I think we'd all agree that's true, right? The contrapositive is, if the sidewalk doesn't get wet, then it doesn't rain.
You're just saying the same thing in a different way, basically.
That's exactly correct.
My husband accuses me of doing that all the time.
Well, and it's one of the complexities of the English language, that because you got to really careful, a lot of times a pastor or anybody giving a speech, they'll say it again, but they'll say it in a different way the second time, right? A lot of times the contrapositive is a good way to kind of reteach something, because it looks at it from a slightly different viewpoint, and it might cement the idea in a person's head. Anyway, so these two guys, those two other guys are, I guess you could call them the bad guys. If you take any statement and write its converse, well, it's no longer the same statement. And likewise with the inverse. Actually, these two are equivalent to each other, but this is the important one, that if you start with this and take the contrapositive, they are equivalent. And by the way, I'll just prove it to you. I mean, here's basically what we're trying to prove right here. Is it true that if P then Q is equivalent to the contrapositive, if not Q then not P? Well, let's find out. I think I've got that down here, or let me see if I do or not. Let's do it, okay? So I'm trying to, there we go. I need a little more space. So you guys all know, I'm going to just make a quick truth table here. We got PQ. And on this side we have not Q, if not Q, then not P. So it's there's only two letters, PQ, so I only need 4 rows. I don't think you have to write this down, guys. Right now, just see if you can follow what I'm doing. So I'm setting up a standard truth table. as you know, the only time if P then Q is false is right here, right? When the first one is true and the second one is false. Yep, the other three are true. So this is kind of what? This is my answer on the left side. Now let's do this thing over here. Well, what's not Q? Well, it's the opposite of Q. So that's TFTF. So not Q is FT, FT. And what's not P? The opposite of TTFF. So that would be FFTT. Now, let's do this if-then. Okay? Only false when the first is true and the second is false. False, false. True. True, false, that's the bad boy, right? You can't, and if-then will be false if the first, only when the first is true and the second is false. Okay, here, this is true, and this is true. So here's the answer on the right side.
Mm-hmm.
Do you see that they're identical?
Mm-hmm.
That proves what this claim up here that I made to you. Okay, remember I said if you take the contrapositive of a statement, that's always equivalent to the original. And I just showed you that's exactly what happens. Why are they equivalent? Because the truth tables come out exactly the same. Okay. If you look on the website, I show it to you this way, where I actually work out all the truth tables. And here's the original, here's the contrapositive, and you can see they're both TFTTs. You can see that these two guys do not equal the original, even though they are equivalent to each other, but what's important is they're not what the original said. So, once again, this is very important that whenever you see a contrapositive, you know that you've got the same thing as the original. Or, if I give you the original, can you find the contrapositive? Oh yeah, flip the two letters around and negate them both. Okay. Next slide here. All right, now there are some more language considerations. I've already given you, I don't know if you heard, I can't remember if it was after we started recording or not, but we were talking about the word but and. I don't know if that was just Cindy and I. But remember how I told you the word but in logic is basically the same as the word and? Does anybody remember that?
Yep, I have it written down.
Okay, so if I say, I'm going to the store, but I don't have any money. That's the same as I'm going to the store and I do not have any money. I mean, it's so from a logic standpoint, I know but means something slightly different. But from a logic point of view, just regard but as and.
So Ron, in the text, it says that and, that conjunction, that downward one, or that pointing up arrow one.
Yeah, this one.
And, but, nevertheless, still, and however. Is that correct?
Yeah.
Okay.
I don't. That. Thank you. That's actually more complete. But you notice. So I was just talking about but you're right. There are other. And there's probably more than that, you know. English has so many crazy ways to say the same thing. Yes, that is correct. Okay, now I'm going to add some different language considerations for you, okay? Sometimes when you're working with language, you will see the words only if. You know, you may go to the store only if you finish cutting the grass. Or, you know, whatever. You know, we use that. Whenever you see something only, you know, so here I just put it in general terms. P only if Q. It turns out that that's exactly the equivalent to if P then Q. So if you ever see, like A only if B, that's the same as if A then B. But when you first see it, without me warning you, you might not know that. Okay, here's another one. The words, and by the way, that underlined word there should be in your notes as a term. Sufficient. If P then Q is, or the if guy is sufficient for the then guy. So in other words, if it rains, then the sidewalk will get wet. So rain is sufficient to get the sidewalk wet. And the thing on the then end, the Q, is necessary for P. So if it rains, then the sidewalk will get wet. The sidewalk getting wet is necessary if it rained. So the easy way to remember this is the thing on the if side is sufficient, and the thing on the then side is necessary. And by the way, necessary, another term, should be highlighted in your notebooks. So these are just kind of facts I'm giving you that'll come up periodically when you're looking at an assignment. You'll see the word sufficient. It's sufficient it's sufficient. Why? What's a good example from life? It is sufficient to have your tax forms handed in before April 15th in order to be legal. So it's sufficient for you to hand in your taxes before April 15th. If you legally handed in your taxes, then they absolutely had to be handed in before April 15th. I don't know. I'm just trying to show you the difference between the two. I like the other one with rain better. So if it rains, then the sidewalk will get wet. Rain is sufficient for the sidewalk to get wet. The sidewalk getting wet is necessary if it rained. So once again, the if part, sufficient. The then part, necessary. Any follow-up question there?
How do you apply this?
What I just gave you some examples of that.
Right.
When
But
you're going to get sentences that will have words like sufficient and necessary in them, and you can actually turn them into if-then statements.
Okay, that's what I meant.
That's basically why this is important. And you might get a question that has the words only if in it, and you'll go, well, he never taught me anything about that. Well, but I did teach you about the if-then statement. So basically, words like this come up in the English language. You have to know how to turn them into an if-then statement, and that's the application. Okay, now number 4. You're going to also see the word implies. What? That's the verb form, P implies Q, and you also know the noun form, implication. So here's how this works. This is also very important. If a sentence says to you that P implies Q, the only time that can happen, this is a big step to use that word, because the only time one thing can imply the other is that when it's put in an if-then form, if P then Q, it has to come out to a tautology. Now, you guys remember what a tautology is?
I've never heard that word before.
Okay, well, now we have. A, ta a tautology is a truth table that comes out true all the way down.
Okay.
And by the way, and not quite as important, but if you get F's all the way down, that's called a contradiction.
Okay.
So a tautology then is, you know, if it's 4 rows or it's 8 rows, whatever, it's got to be, the answer has to be T's all the way down. That's a tautology. Obviously, that's a very desirable thing, because if you get a tautology, then that means, well, this can't even be false. This is always true. Kind of like a theorem, you know, something that always works. Okay. By the way, whenever it actually, the if-then does come out to a tautology, we actually promote it, and we use this symbol right over here. You see it there? It's like a double, it's like an equal sign with an arrow on the right. I always say to my students, it's like we promoted it. We gave it an extra stripe. So if P then Q turns out to a tautology, play the horns, da-da-da-da-da, because this is special. P implies Q. That's what this says. P implies Q. And we're going to practice that in a minute. So how do you know if you have an implication? There's only one way. Set up an if-then situation and do the truth table and see if you get truths all the way down. And that's of major importance. Okay. Yeah, I know that's a lot, but there's all this language stuff we needed to talk about. Add that to the and but situation. It's almost like an English class today. Yeah, this, by the way, this is just the way, this is the book saying what I just told you. You see what I've highlighted in yellow?
Mm-hmm.
The statement P is said to imply the statement Q if and only if P then Q is a tautology. So if it doesn't turn out to a tautology, we don't have any implications. Okay, so I guess we need to do one to see. So why don't we observe this one first, okay? So here's one way on the top. You see where it says, show that this thing in brackets implies Q. So the only way to find that out is have that thing in brackets be the if, and then put Q on the right, what I've got right here. So I set up a truth table to do that. Don't write this down. We don't have time, okay? And there's an example. It might even be the same example in the book. I don't remember. So anyway, look what happened when I did the truth table. Here's the answer right here underneath the underneath the arrow. And do you see how it came out to a tautology?
So it's just the answer that needs to be all teed down, not how we got there?
That's correct.
Okay.
Yep, that's all it is the answer. That's still asking a lot. How many answers have we had that were true all the way down? Probably none up until this one. So believe me, it's still really special. And so that's why I wrote tautology, double exclamation point. This is a big deal. And because it's a tautology, what can I do? I can actually put the implication symbol. Not just this, not just the if-then, but I can actually now promote it and say, hey, this thing over here implies that. Big here, this is a big deal.
So, question, for that, would the answer be just the T's, or I show written down you have the implication symbol? You need that as well?
No, I mean, with the way it's worded, it says show that it implies Q. This really shows it right there.
Okay. So that's technically all we need.
Yeah, but I'm getting you used to the terminology and the symbols.
Okay.
That's the only reason I talked about what's down below.
I just wanted to make sure for like a test
Yeah, if you had a table, you would be done right there.
Okay, thank you.
Yeah. So, and by the way, you guys know how to do a truth. I mean, that's what we practiced last time. I mean, how well practiced we are, I don't know, but so that the actual making of the truth table, I didn't take the time to go through it, but really all I did was follow the basic rules. Okay. Let's see what's next here. All right. Now you remember some of those crazy words. I think if you look in the assignment, you'll see some of those. So you got your book handy. Let's just take a look at some of the early exercises. Yeah. Okay, take a look at number 3 on the bottom of page 142. If you got, hopefully you got your books handy. It says there, you have no cavities only if you brush your teeth with clean. You see that? Is there anyone who doesn't see that problem?
I don't have my book in front of me. I can go grab it though.
But anyway, you did hear that 2 of the words in that sentence were only if.
Yep.
Now, do you remember what our discussion about that was? If you ever have, you know, P only if Q, that's the same as if P then Q. So in other words, this is just if you have no cavities, then you brush with clean. Okay? Remember how I told you P only if Q is exactly the same as if P then Q. So in other words, you can get rid of some of that extra English baggage that's in there. Yeah. So.
Would you use that double arrow sign?
No, I would just say if P then Q. I'm sorry, or oh well, they use a they call. All right. Bad example. If you look, you got to look at the stupid directions for number 2. But anyway, it's just if the first thing, then the second thing. It just turns out by this what they said in number 2, having cavities is Q. And brushing your teeth with clean happens to be P. So it's really saying Q only if P. Well, how does that translate? If Q, then P. So this only if stuff is really a lot of wasted, confusing words, to be honest. Okay? Especially if you're into logic, it'd be a lot better just to say if Q, then P. Simple, direct. Let's see, another example. Okay, look at number 10. If you don't have it, just listen. Here's number 10. To have rain, it is necessary to have clouds. Okay, let me write that down.
So necessary.
Yeah, do you remember the word necessary from a little while ago?
Yeah, I do.
Where does necessary go? On the dull end of the arrow or on the sharp end?
The sharp end.
That's correct. So, it's necessary to have clouds. To have rain, it is necessary to have clouds. So, because of the word necessary, labeled with clouds, I put the C at the sharp end of the arrow. So, this is the logic equivalent of that statement in number 10.
So that would be the answer.
I don't know, do they want it in words?
They wanted it.
I would say, I mean, I can't tell. I think they might want words. What do you guys think?
It says symbolic form.
Does it say that above number 6?
Which one are you on now?
Number 10.
Oh, sorry.
Yes. No, you're probably right, but they don't say that.
Statement and if then form.
In the if-then form.
Yeah, but that could be symbolic too. Anyway, the answer to this is if it rained, then there must have been clouds. Or if it rains, then there must be clouds. Right? If it rains, sorry for the bad penmanship. So that's, I would write the answer that way. I guess I'm getting an echo. I don't know, somebody must have a pretty loud speaker on their computer. It's coming back. Okay. So do you see how we had these word considerations? Do you see how these words are going to come back and how you have to use those? So when you see the word necessary, oh, that goes on the end. If you see the word sufficient, oh, that goes on the beginning. If you see the words only if, you can basically ignore it and just do if the first part, then the second. If you see only, yeah, we already did only if. Here's another one where you got to use your noggin. Look at number 14. It says all dogs are canines. You're supposed to change that into an if-then statement. Can you see how to do that? All dogs are canines. Isn't that just saying if it's a dog, then it's a canine?
Yeah.
Yeah. So do you see how you... This isn't just math. You got to kind of use your English skills here and your analysis a little bit to turn... So all of the ones in that 6 through 14 you have to change into if-then. Oh, and then here's another wonderful one. Well, you've already seen this. Number 16, it says honk if you love ultimate, which is some Japanese car. But do you see how once again they put the if part at the end? We can do that in English too. Basically, English, there aren't too many rules. You can do just about anything you want. But in logic, what do we want to do? We want to put the if part first. So what does that really say? If you love ultimate, then honk. Right?
Mhm.
Okay. All right. Let's go on to another slide. I was trying to give you examples here. Yeah, we've already gone through a bunch like that. Okay, now, way at the end of this assignment, if you have your book, maybe, look at the bottom of page 142. Maybe you guys could turn your volume down a little bit, because I'm getting some pretty bad feedback here. So if you know how to do that, maybe turn your volume down just a little bit. Thank you. Anyway, on page 144, at the bottom of the first column, do you see where it says implications? Okay, that's that. I've duplicated that on the screen there. See it? Now, check these directions out. It says in problems 48 to 54, 2 statements are given. Do you see how they put a semicolon between them? Like in number 48, there's the first statement. You see that semicolon? There's the second statement. So in each problem, do you see how they gave you 2 different statements? You're supposed to, and here's your task, determine whether they are equivalent, or one implies the other, or neither. Okay, what does it mean if the 2 statements are equivalent? What happened? What do you know about equivalent statements?
They're equal.
Yeah. So in other words, if you do the two separate truth tables, they should come out to exactly the same answer, right? Okay. What's the second one? How do we know if one implies the other? I just taught that to you today. You if one and then the other, and it has to come out to a tautology.
So they're both answers are entirely true.
No, no, no. That's not what I said. If you if one and then the other, the if then turns out to a tautology. That doesn't mean the statements are.
Oh, okay.
Okay, and it might happen that neither of those will happen. They might not be equivalent, and there is no implication. So, all right, let's take a look. Here's the first one. Look at number 48. So here's the first thing. Here's the second thing. But why don't you just look at the truth table right now? Here's the answer to the first statement, FFFT. Over here, here's the answer to the second side, FFFT. So what happened? Are they equivalent, or does one imply the other?
They're equivalent.
They're equivalent, right. Actually, yeah, let's not go any further, but actually if you did an if-then, if you put this in, that would turn out 2, but we can stop with an equivalence. Okay, now look at this. Here's another one from that assignment, number 50. So here's statement 1. Oh, good grief. Okay, I have the wrong. Here's statement 1. Here's statement 2. Do you notice that can you see that the answers did not turn out to be equivalent?
Yeah.
The columns are not alike, right?
Right.
Okay, but so now I got to see, does the first statement imply the second? So I want to know, does if 1 then 2 turn out to a tautology? Well, what's the rule for if then? Only false when the first one's true and the second one. So this one here is, I'm getting this echo really bad tonight. If true, then true is true. If true, then true is true. If false, then true is true. Oh, too bad. That does not come out to a tautology, correct?
Correct.
All right. But now, this might shock you, but we got to try one more thing. We got to try this. Might 2 imply 1? If you can think backward, this is your if and this is your then. If true, then true, true. If true, then true, true. This is false. Nope, that doesn't work. So they're not equivalent, and they don't imply each other. The answer is neither. But did you see we had to try 3 things before we came to that conclusion? What was the first thing was when we found out if they were equivalent or not. That was pretty easy. Then the second thing was we tried if-thenning, if 1 then 2, if the first part then the second. That didn't work. And then we had to do if 2 then 1, and that didn't work either. Okay, neither. So those last problems are pretty demanding. You might have to even go through the problem like we just did 3 times before you come to your final conclusion. Let's show you. Let's do one more, okay? Let's take 52, which is also from that section. All right. Here's the first statement. Here's the second. The second, if you're wondering, that's only P. Yep, that's what they have there. Whoops. That's what, sorry, keep grabbing the wrong tool. That's what they have right there. It's a P. So that's the second statement. So all I had to do is copy my standard column over here. On this one, I had to do this P and P or Q, and that came out to TTFF. Well, this time we got it easy because do you see that the two asterisk columns did come out to the same thing. So here they're equivalent. Do you see that? You're probably, I don't mean do you see how I got every T and F, but do you see that the first statement answer is right here, the second statement answer is right here, and that they're identical?
Yes.
Okay, so that one you would write, you know, equivalent. So, okay, so that last section, when you get to the 49 part, well, you got two of those, 49. I think you might have three of those, 49, 51, and 53. You got to consider it's, if you get an equivalent like we did, you're lucky. You only have to go through it once. If you then get an implication, well, that might be on time 2 or time 3. But if all of those fail, then you've got one of those neither answers. Okay. Assignment. Read at 53, the odds. I wanted to go slower, but I'm already over, so sorry. Always a little bit of a fight. I don't like going too fast, and yet I sometimes feel like I don't know. I'm caught on both ends. So, do you wanna get some more clarification? Any questions?
I think I got it.
That's good to hear.
Yeah, just ready to try them.
Okay. Well, thank you all for joining me tonight. Have a good rest of your evening. Sorry we kind of cut into the middle of it. Cindy, apologize to your boyfriend for taking up Sunday night.
He's already snoring.
Good night, everyone.
Good night.
Thank you.
Thanks.